Okay, welcome back. So the only announcement that I have is the one I posted on Friday. If I'm hearing that some of you are having trouble with installing either VirtualBox or Ubuntu, and you're coming across this error or something like it. There's this YouTube video that a student sent me, and it helped this one student. So if you're having problems, just try that and let me know if things still go haywire. What starts today? Labs. So have fun. This should be the easiest lab or assignment of this entire class. So take advantage of getting those points. Any questions? Yeah.
So do you need a Windows computer or use a Mac for this?
You can use any environment that you wish. I use a Mac. I actually tested Lab 1 both on my Mac and on my Ubuntu virtual machine. It works on both of them. So you can use any environment you want, yeah. For an iPad, I'm not sure if you can compile because that's against Apple's App Store guidelines to have a compilation program. But you can, if you have an iPad, you can go to, say, cpp.sh, which is the link down here. You won't be able to test against the test cases, but you can compile and run your program there too.
So pretty much everything.
Yeah, but if you are lacking any particular thing, you could always use any of the computers freely available to you in any of the labs here on campus. Any other questions? So assignment 1 is not finished yet. The TAs are still working on test cases, but I expect to get it around by Wednesday of this week. And it'll be due the next Wednesday. Okay, so let's get back to material stuff. So last time we had a fun example using cout, and then using these things called escape sequences. So if we wanted to print a new line, then there are 2 ways that we saw of doing that, using this endl, whatever that is, and then this \n thing. So those are the 2 ways that you could print a new line. But then you may be thinking, okay, let's just say that I'm trying to print a tutorial for a user. So like, we're going to make a nice tutorial for someone new to C++, how to use C++. And we're going to write it in C++. But let's just say I wanted to print out the cout, less than, hello there, everything else. Well, we saw last time how to actually print a quote character. And how did we do that? Yeah, using the / quotation mark thing. And you may think, okay, what about the / itself? How do I print a /? What do you think? You're right, so a /. So this / thing seems to have some importance in relating to printing things to the screen. And that's what's called an escape sequence. So an escape sequence means / something. And what that means is that when you do the / whatever, some special action is going to be performed. So in the case of \n, \t, either a new line is going to be printed or a tab is going to be printed. So these ones are less common than the top 2, but they have had some use before. The other 3 that are more common are \\, if you want to actually print a \, a single quote or a double quote. So if you wanted to print a single quote or a double quote, then you would do an escape sequence for that. Because if we just try to just put quote there, then that'll be the end of this quoted whatever the thing is called. So if you want to actually print a quote, use an escape sequence for that. \ is different from /, as we'll see later in these slides. So \ is the only way to get an escape sequence. /, which is the one going from the, let's see, bottom left to upper right, that has a completely different use in C++. But could the C++ Standardization Committee say, Oh, the forward slash, that is for an escape sequence, and the backslash is for the other purpose. Could they have equivalently done that? Yeah, so there's nothing truly special about a backslash. It's just that they defined it to mean use an escape sequence. So the backslash n thing, that, or any escape sequence for that matter, it has to be inside the quotations. Otherwise, it just doesn't work. Endel has to not be in quotes. So if we go back, endel is not in quotes, but backslash n is. Because escape sequences are what are called characters, and characters have to be inside quotes, whereas endel is not. Yeah, so put backslash n in quotes. Okay, so let's get on to this pound include whatever this thing is. So whenever we see something with a hashtag symbol in front, what is that called? A preprocessor directive. So hashtag include, that is a preprocessor directive. So the purpose of this preprocessor directive is to take something from some other program and literally copy and paste it into ours. So that if we want to use some code from some other file, we don't have to copy it ourselves. We can just say, oh, I want to include that code that has this nice thing that I want to use. Just include it, and everything will work fine, which is pretty cool. So if we look back at the example that we did last time, we saw that we have this hashtag include IOStream. So IOStream has code that we want to use. What kind of code do you think it contains? Just by looking at the name, IOStream. Right. So the IO in the IOStream stands for input-output. So if we want to have some code that's related to getting input or producing output, IOStream is the way to go. And you may be wondering, oh, okay, well then why don't they just call it IO? Why is this stream thing here? We're not there yet. But the stream here is basically using the double less than symbol. So those are what are called streams, but we'll get to that eventually. Yeah. So it's a preprocessor directive, meaning, so remember, we're copying things from another program into ours. So it can't be part of the language because the language is program agnostic. It's not dependent on what is written into a particular program. The language is independent of any program that's written in that language. So if we're copying things from another program into ours, it can't be part of the language for that reason. It's not seen by the compiler, right? So what thing in the compilation process, the entire thing, sees these preprocessor directives? What one of the three steps sees it? So what are the three parts? Compiler's the middle one, obviously. What are the other two? Preprocessor and linker. So which one of those three do you think sees the preprocessor directive? Preprocessor. Yeah. So this is just an example. And so we'll be talking about a whole bunch of these directives throughout the class. The first one, obviously, we've seen is IOStream, but we'll see many more throughout the class. Here, there's no semicolon. So this is not actually a statement. It's just a preprocessor directive. So what if we wanted to actually put a semicolon on here? Do you think it would work? Would be one way to check. Compile it. Let's just see what happens. So let's go to terminal, G++, our main file, and there was no compilation error. So what do you think happened here? Yeah, kinda. What if I did two semicolons right at the end? Would that work? Let's test again. And it does. So what do you think happened here? This is a good exercise to think about. How big is this statement in between the first semicolon and the second one? Empty. So you can have empty statements that have nothing in them at all. It's probably not a good idea to have this because it's additional burden on the user or the programmer to look at that and say, oh, the person programmed this, hit their head when they were young and they're crazy to do this. But it's allowed. So you have to think about what is actually allowed in the language versus what is actually useful to actually program with and to actually understand. Doing this is allowed, but do you think this is a good idea? No. So the convention is to not have a semicolon at the end of a preprocessor directive because it's not a statement. But could you put a semicolon there? Yes. Yeah, you can. So I'll be saying things throughout the class about what is actually convention versus what is allowed. Try to stick to the convention because if you're going to use code by other people or have them use your code, you want to stick to the convention. So the convention here is no semicolon. Okay, any questions on what #include does? Okay, so the next thing is a variable. So a variable, I've mentioned last time, is just a piece of memory that holds a particular value and can change throughout the course of the program. Let's see. Yeah. So an assignment statement, which is how many equal signs for an assignment? 1. What is 2 equals? Check equality. So a single equals means assignment. So for an assignment statement, are we assigning from the right to the left or from the left to the right? Left to right or right to left? Right to left, right? Because if I, let's just say we wanted to make a int variable and set it equal to 5, this will work, but I can't do this. I can't assign from the left to the right. I assign from the right to the left for assignment statements. For a variable, as the name implies, it means that the value can change throughout the course of the program. We'll talk about not a variable, but something called a constant later on, meaning that it doesn't change value. But a variable can change value throughout the course of the program's running. So this is, of course, important. You must define the variable before you use it, right? So if I declare a variable up here and I use it down here, what is that type of programming where we start from the top and work our way down? And it ends with procedural. Procedural, right. So this is a procedural language from what we understand so far. And so because of that, we need to declare the variable before we actually use it, obviously. So declaring the variable before we use it means put it up top or higher above where you're going to use it and then use it later. So an example of this would be our handy program here. Let's just say we make a variable called x and I give it the value 42. We don't know what int means here, but it's just to get the program to work. Then maybe what we can do is, let's just say we want to print after Michael Scott here. We want to print his age in parentheses. Let's just say he's 42. I'm almost guaranteed he isn't. But let's just say I want to print 42 like this. Would this actually print parentheses 42 if I just ran this program? How can I check? Compile it and run it. So if I compile and run, I'm not sure why that didn't work. Let's try again. Yeah, okay. I'm not sure what happened there. Yeah, I'm not sure what happened. So this does work, but let's just say that this input somehow was gotten from the user in some way. We haven't talked about input yet, but let's just say it was gotten from the user. And let's just say the user happened to enter 57 instead of 42. In how many places do I have to change 42 now if I wanted to change that value? 2 places. What is better than 2, but you can't quite get to 0? 1. So if we wanted to have something where we only needed to change it in 1 place versus 2, that'd be better. So what would be the better idea than printing 42 in here, in the quoted part? Okay, so what we can do is, let's just end the quote right here because we have to print the parentheses no matter what. And then what we can do is chain the output part by saying, what am I going to output here? Am I going to print 42, or what should I output instead? The variable, and its name is? X. Good. And so then what we can do is chain again the ending part, which is the ending parenthesis, which we have to print anyway. So then if I run this, we should get the exact same output, and we do. If I change this to 57, compile and run again, then it changes. So this is really nice in that I only need to change this in 1 place versus 2. And so basically the first half of the class is understanding various parts of C++, but the second half is trying to get something like this, where you have a whole bunch of places where you may need to change things if you need to add a feature or something. But then we'll try to minimize that by saying, if we use this concept instead, I only need to change it in 1 place for it to all work. Okay? So this cuts down on the maintenance of using a variable. But let's just say we wanted to add 1 to x. Okay? So it's 57. I could just write 58 here. But let's just say that the user could enter anything there. How can I add 1 to x? Well, what kind of statement should we use to update a variable? An assignment. Do assignments assign from right to left or left to right? Right to left. So let's just see. What variable am I updating? X. So what should go on the left side? X. Okay. What should go on the right side? Well, a value of some kind, but we want to change it from its old value of x and add 1 to it. What is the old value of x? X. Well, then I want to add 1 to it, which is plus 1. So this may seem a little wonky, but this value of x on the right side is the old value of x, the one before this statement even occurs. So this value of x has value what at this point? The one on the right, 57. The one on the left after this statement is performed has value what? 58. Okay? So remember, assign from right to the left. So if we compile and run this, well, that's weird. I genuinely don't know how that happened. That is really weird. That should absolutely work. Okay, I have no idea how that happened, but I'm going to investigate, and I'll let you know if something interesting happens. But this really should happen. You should really get 58 out of it. Yeah, I have no idea how that happened. But this is what should happen. Any questions on how, yeah?
So you don't have to establish that it's an integer again.
Right, yeah. So, great question. So this is an integer. We'll get to what integers are later. But this is the type of x. So we're saying x is an integer. It can take integer values. So this only needs to happen in the declaration of x, which is the first time you define x. But if you use x later, you don't have to rewrite that int over and over again, which is cool. You only need to say it once here. Okay? Any questions otherwise? Yeah.
Does it redefine x every time you run the program? So if you ran it again, would it be 59 and 60?
No. So when the program stops, the memory, in a sense, is wiped clean. And then when you rerun the program, it's brought into memory and then initializes the value of x to be 57. Yeah, so we can actually demonstrate this by running again. Although, given this example, we might actually get 59. but it really should be the same every single time. Any other questions? Yeah, I'll take a look into that. That really shouldn't happen. I'll probably say that a lot in this class. Okay, so this is an example of the assignment statement that we did before. So if a new value is stored like in the x plus 1 equal to x statement that we just did, it overwrites the previous value. So what was there originally is destroyed in some sense. The new value overwrites the previous one. And it can't be retrieved no matter what. So if I have an integer called age, I set it equal to 17. This prints 17 because age's current value is 17. And then I set it equal to 18. That overwrites the 17. And so 17 is wiped away. Now 18 is what's there in the variable called age. And then when I call cout on age, it prints 18 now. The assignment uses the single equal operator that we saw before. It has to be a variable on the left side, no matter what, and some kind of value on the right side. It could be an actual value, or it could be a variable or a combination. But the left side has to be a variable. Yeah, so it copies from the right to the left, as we've established already. Yeah, go ahead.
While printing the variable.
What's there?
While printing the variable, should when we print like age, the top.
Yeah. So when we print age, yeah.
So should we like that, or just double?
Oh, great question. Yeah. So let's actually do this instead. So let's actually just cout x, just to keep things simple, and then a new line to make it look nice. So then if we compile and run this guy, it should print 57 or 58 from what we know. The question was, what if I did this instead and put quotes around the x part? What does this print? X. How can I test to see if it works? Compile and run it. Okay, something's up. Who hacked into my computer? Yeah, that wouldn't work either. Okay, wow. Oh, I know what happened. So if I run Ada out over and over, does it change? If I save the file, don't compile it, just save it over and over and over, does Ada out change? No. So what I think happened was it's compiling, but I accessed the old A.out file. I didn't wait long enough. So if I change this back to x, which should print 57, if I wait, then it should print 57 as expected. Then if I change it and wait, then it should print x. So yeah, modern file systems are weird. So how many of you have heard of what is called a race condition? So what happens is your system, so this is just a tangent, but it's actually pretty useful. So if you have your computer, you usually have a whole bunch of cores. So you have a whole bunch of things executing at the exact same time. So let's just say that the terminal right here, I'm trying to access A.out, right? I'm trying to run A.out. But the compilation part of it is a totally different what is called process. It's a thread, but think of it as a process. So G++ is trying to write to a a.out file, and I'm trying to access an a.out file. So I'm trying to access something while this one is trying to overwrite it. What actually happens is if I'm too quick, I'm trying to access the old a.out file. So then if I run again, then if I wait a little bit and run again, then the G++ command actually fixed the a.out file to be the new one now. So that's why we saw the 5758 from before. Okay? So I just needed to wait a little longer. I'm a little too quick. Okay? Does that make a little sense? Okay, good. So hopefully this makes sense on why we shouldn't do this, because this will print the literal character x. It doesn't print the value stored in the variable x. Okay? Yeah, go ahead.
The previous, we were talking about microscopic thing.
Yeah.
There was a teleportation.
Oh, what, sorry?
There
What?
was teleportation.
Yeah, right here.
Yeah, so what does that mean?
What do you mean help you? I don't know what you mean.
What does that mean if the x is between?
Yeah, so I'm chaining cout statements together all in one statement. I could have equally said this. I could have equally done that, that's fine. But it's just I wanted to put them all in one line. There's really no difference between them. Okay, any other, yeah.
At the end of the cout statement, you don't like close the bracket. It's just the two actual brackets. Big.
Yeah. But then if I wanted to change these, I need to put more of these and something in between. But if I wanted just one, I could just do that and I'd be fine. Other questions? Okay. Glad I figured that out. Okay, so assigning a variable is pretty easy. We understand how that works. Assigning a variable assigns a value to a previously created one. Single equal, as we saw before. The third one here is not legal because we're assigning from right to left, and the thing on the left is not a variable, so therefore it's not legal. Initializing a variable is a little different. So it's when I'm declaring a variable, so when I put the int or whatever on the front, and I give it a value at the exact same time. So in the example that we've been working on, this one is just an assignment, the x equals x plus 1 thing. This one is an initialization, because I'm declaring the x for the first time right here using the int thing, and I'm giving it a value at the exact same time. What about this? Is this first line an initialization?
Yes.
Technically, yes, but are we initializing it? No. With an explicit value, no, we're not initializing it explicitly. Okay? So this is an initialization because I'm giving it a value and declaring it at the same time. Yeah, so this is just where you have the int or whatever on the left side and you put a value there at the same time. Although this one, so there are things called explicit initializations and implicit initializations. You don't need to know what that is. But this one happens to be an implicit initialization because we're not giving it a value. Any other ones are explicit. You can have multiple variables of the same type, whatever that is. So I can have two ints right here, whatever those are, one called length, one called width. That's totally fine. Or I can declare them in the same statement if I wanted to, using a comma in between them. Note, I don't have to say int again here, because it is the convention is that you have, if you say int on the front, then every other variable you define in the same statement also is an int.
You put on the same line.
Yeah, yes, of course. I could put this back up onto the same line. Yeah. But if you have two variables of different types, then it must be in different statements. Because I can't have like an int length and then the double width or whatever that is. I must have those in different statements. Okay. So you may be wondering, okay, a variable is a named thing, right? So x is a named thing. What is the 57 on the right here? So that's not something I named. That's the actual value, 57. So that's what's called a literal. So a literal is a value that doesn't have a name. That's essentially what it is. It's a value that you directly write into the source code. So 57, 12, 5, all of those are literals. And here are some examples. So anything in quotes at all, those are literals. An actual value like 12 or 57, those are what are called integer literals. This is another quoted one. Something called floating point, we haven't gotten to that yet. But it's just a value that I write into the program. It's not a named thing. But it's just value. That's all it is. Any questions on literals? Yeah.
What's the difference between 12 and
Yeah. So remember, this is the actual value 12. The thing in quotes is the character 1 followed by the character 2. It's not 12. So integers and what are called strings, those are different things. So a string thing is just a bunch of characters together. An integer is just a bunch of bits. And it's not stored in the computer as 1, 2. It's represented by the binary of whatever 12 actually is. But strings are represented by 1, then 2. Okay? Other questions? Okay, so identifiers, same thing as variables, but this is just really about the name of the variable itself. Could I, in our program over here, could I have given x any name that I wanted to? Essentially, as we'll see. But does it have to be called x? No. But do you think that there's a purpose to having a name be a certain thing or a certain style? So what if I'm writing a C++ program for people in mathematics? Does the name X make sense? Right. So what if I'm instead writing an application where there's some business transactions that are being made and X is the input from the user? Does the name X make sense in that context? Probably not, maybe, but probably not. So understanding what variable names are useful for that particular context is pretty important. But we're gonna, so that's not really enforced by the language. You can have any identifier pretty much that you want. But it's just that you should follow that convention, whatever program you're making. Because it's easier to read that way. Yeah, so you choose names to represent the parts of the program. The name should indicate the use of it. So if I make a variable that gets input from the user, a good name for it would be what? What would be an example of a variable name to get input from the user? Input, or input 1, or something. So it indicates in its own name what it should be used for, so that it's easier to work with later on. I could call it A, B, C, D, E, F, G, H, but that's probably not a good idea. You can't use keywords as identifiers because keywords have a unique purpose in C++. So here's the rule on what identifiers are allowed to be. So they defined it to be this way. They could have equivalently defined it to be something else, but this is how they defined it. It must start with an alphabetic character or an underscore. So any of the 26 letters, either lower or uppercase, or a underscore. So the first character must be one of those 53 letters. And yes, I counted. And then after that first character, those 53 plus all numeric digits are allowed also. So I could, let's see. So I could say x012, and then that would be a perfectly valid variable name because it starts with an alphabetic character, and it has either alphabetic or numeric characters after that. So let's just do a short, not here. It's on the next slide, I just remembered. The variable name should reflect its purpose, as you might expect. You can have multiple words here. And so the words are not really words, but since it's all one word, but here's what's the convention here. So what you do is one way is to capitalize all words but the first letter of the first word. So if I have a identifier name like this, it's saying quantity unordered, even though that's just one long name, it indicates to us 3 different words. Or total sales, that's another way. So this is what is called camel case, which is, I could have equally said capital Q on here and capital O, if I wanted to, but this is just a convention. Or you can use the underscore character as a space. Could I put an actual space here? No, because it's an identifier name. It has to be one contiguous set of characters without a space in between. But you can achieve a space by putting an underscore there. Yeah, so use one convention throughout the program. So let's just do a quick quiz. It's not graded, but is the first identifier a valid name?
Yes.
Yeah, because it's just all alphabetic characters, no issue there. Is the second one valid? Yeah, because I said that you can have alphabetic or underscore throughout. Could I have complete underscores all the way through? Yeah, because it's just capital a letter or underscore, and then those same things or numbers. So I can just have a bunch of underscores if I wanted to, although that doesn't really work well for readability. What about the third one? No, because why? It has a dot in between. What about the fourth one? No, why not? It starts with a number. What if I interchange the T and the 4? Yeah, that would be fine, because only the first character can't be a number. Any of the others can be. What about the fifth one? No, why not? Because there's a dollar symbol, and dollar symbols can't be used anywhere. In other languages, though, dollar symbol is required. So there's a defined set of identifier names that are allowed. Could they have used a different set of identifier names as what's allowed? Yeah, because they're defining the language to mean what it is supposed to do. They wanted it to be this way. Okay, so let's start sinning. It's cin. So we saw cout before, which outputted things to the screen. What do you think cin does? Does input, right, from the name. Note, the name reflects its purpose, right? So they wanted it to reflect what it's supposed to do. So cin means input. It again requires IOStream, but you don't have to include IOStream multiple times. You just need to include it one time. Used to read input, and is often used with cout to display a user prompt first. So if you wanted to have the user, let's just say, input exam scores, which I might have to do, you can just say, give a prompt cout, enter a score between 0 and 100, and then right after that, I'll have a cin statement to actually input that value. So that's what's commonly done. So note here, cin is 2 greater symbols, not 2 less than symbols. And the reason for that is, well, they defined it to be that way. But another reason is that you put the variable right after the cin and the 2 greater symbols, which indicates it's coming from cin going into the variable, whereas cout, it looks like it's going to the cout variable. Again, they could have defined it differently, but that's how they defined it. Input data is stored in one or more variables. So you can have multiple inputs here. user input goes from the keyboard to the input buffer where it's stored as characters. That's not really that important. The cool thing is that you don't have to worry about what type the thing is you're working with, whether it's an int or double or string or whatever you're working with. It converts it automatically, which is nice. So this is just an example of how this works. So I declare a variable called height of type int. Then I'm going to print to the user how tall is the room, and then I'm going to cin height. So what's going to happen if I run this is it's going to immediately print the cout statement and then just hang there waiting for me to enter the input. And what happens is I'm going to type on the keyboard, obviously like this, and then what happens is when I push the enter key, then all of whatever I just entered passes through cin. So it waits for me to enter until I push the enter key. So let's just see this in action. So let's go back to our Michael Scott SpongeBob example. And let's just say, let's have the user enter the integer x and not just hard code it into our program. So let's give a prompt. So let's just say cout enter an age for Michael Scott. And then what do I use to input a variable? Cin. Good. Is it to less than symbols for cin, or is it greater than? Good. And then what occurs right after these two greater than symbols? The thing, the variable that I want to be inputted into. What is the variable that I want input to be stored in? X. Well, it's the only variable. So, okay. So then let's actually run this and wait for the a.out file to be stored. So that's good. Enter an age for Michael Scott. What is an example age? 50. So 50, and then, so our program now adapts to user input. So we have the input occur, and then the computation, which is merely just printing things, that will occur with this input that was received. And so now we can get input from the user. Yes?
I was just wondering, like, after the cin, if you put, like, the x equals x plus 1 again, would it do 51?
Yeah, it actually would. So let's actually run this and see what happens. And wait. So let's put 50 and it'll print 51. So note here, once I get the input from x, then x just behaves like a normal variable, right? So cin, what happens on the back end of cin, you don't see an assignment taking place here, but on the back end in cin, it does an actual assignment in there somewhere. So that's a nice thing about C++. I can redefine this operator to do some other work to make it more clear what it should do. You have a question? Yeah.
Well, I was just wondering if you could put the +1 in the C instead.
No. So the good question. So if I did this, then this is what is called a value expression. And so that won't actually work. And if we actually try to compile, it won't work. Okay, why does that work? This is not my day. That is really strange. I've never seen this. Great question. So I have another thing to look up. But I did wait. That is very strange. I'll look into that. Yeah.
Why wouldn't a value expression work in that context?
Because it's supposedly. Oh, I think I might know why. But it's a little complicated to explain. So if we try to do this instead, put parentheses around this, this shouldn't work, although it probably will. Yeah, so it definitely doesn't work. So what happens here, I think, so I'll look into this, is that this is what is actually happening. And what happens is the cin statement, when you input to x, actually gives you the value back. Okay? So what happens here is the value is being returned, and then what happens is this +1 is being applied to that expression using things that we haven't learned yet. So that's probably what's actually happening here. If we do a ×2, let's just see what happens. Let's. Okay, why did that not work? Is it really only for +1? Oh, that's why. Because I didn't wait long enough to save the C++ file. That's why. So yeah, this shouldn't work. Yeah, that would be striking if that didn't work. So here is something called a precedence between different operators, and one is preferred over the other. We haven't learned precedence yet. But what happens is that the precedence order is wrong here, and so something is evaluated before something else. And x + 1, as I said, is a value expression and not a variable. And so it cannot be assigned to. So that's why it doesn't actually work. Any questions? Okay. So let's get on to more CN stuff. So you may wonder, like cout, I can output multiple things at the same time by putting more less than symbols and then stuff after them. You can do the same thing with CN. So if you wanted to input multiple values at once, instead of having a CN thing, CN, 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 I can do it all in one line, which is a nice time saver. Values from the keyboard must be separated by spaces or enter. So this is actually pretty interesting. So if we do this, let's just say, let's just have a 2 variables, int height, width, and then, so let's just have a simple output statement. Height with a comma separating them, and width. Just a simple program to output what we inputted, nothing special. So if I compile this and wait for this to run, so it didn't output anything. What do you think is happening? It's waiting for me to input. I didn't prompt the user here. So if I enter height, let's just say 6 feet, and then the width, let's just say 3 feet, then it outputs what we want. What you can do instead is I can output everything all at once by providing multiple inputs separated by spaces. So if I do this, what it's going to do is it's going to wait until a space is reached. Then it'll consider that first part as the height in this example. And then the thing after the space, the next part of it, that goes to the width variable. And then if we had more, it will keep going until there's no input left to parse. So you could either enter input, enter an input, push the enter key again, or you can do input space, input space, input space, and then enter all the way at the very end.
Is that true for if the data type was like a string?
Yes, it would be the same here. So remember, CN adapts to the type that you pass to it. We haven't talked about strings yet, but if these two variables were of different types, CN works automatically. So like if I had a CN height here, it's expecting an int first, and then let's just say width is a string, then it'll expect a string second. Or it'll interpret whatever we pass to it as a string.
What if the first thing was a string and you wanted a space in the string?
You would need an escape character.
Okay.
Or quotes. That's another way to do it. Any other questions? Great, I'll see you on Wednesday.